In this video, I'm going to look at limits. Now, you might want to watch my instantaneous rates to have a bit of an introduction to limits. What I've got is I've got the function y equals x squared, or f of x equals x squared, and I'm going to choose 2 points, and I'm going to work out what the instantaneous rate of change is between these 2 points. So let's say this is point P. Let's give it an actual value. Let's call it 1, 1, because we know that when x is 1, y is 1, because 1 squared is 1. Now let's pick another coordinate, Q. Now this time, the distance in the x direction between points P and Q is some distance. Let's call that distance h. So that distance across there to there is our distance h. Now, if I'm going to put this coordinate up here, what we've actually got is in the x direction, this point here is 1 plus h, comma. Now, if that's our x, we need to substitute it in here to work out what our y value for that particular coordinate is, and it's 1 plus h all squared. Okay, now that gives me the coordinate of p and the coordinate of q. Now what I'm going to do is I'm going to use my average rate of change to work out the gradient between those 2 points. The gradient, I sometimes use m, is the y, the difference in y, so y2 minus y1. I'll write that down anyway, just in case you haven't done this for a while. So y2 is 1 plus h squared, and y1 is 1 over x2, which is 1 plus h, take away x1, which is 1. Now I can work this out by using a quadratic expansion on this one, so that gives me 1 squared is 1 plus 2h plus h squared minus 1 gives me the numerator, and the denominator just leaves me with h. Alright, now let's simplify this. 1 take away 1 is gone, so I'm just left with 2h plus h squared over h. Now, in actual fact, I'm just going to create some more room. I'm going to factorise this. All right, so I actually will just write it up here. Now, factorising the top gives me h, 2 plus h on the top over h on the bottom. Now, I can simplify this. That just leaves me with 2 plus h. Now, what we've worked out is the gradient between p and q is 2 plus h. Now, you imagine what happens if the value of h gets smaller and smaller and smaller, so much so that q is practically sitting on top of p. What we would say is that h would become 0, or it would limit to, its limit is 0, so therefore the gradient of the line would be of the line pq would be at point P, and we would say the gradient of point P is actually 2. We can also say that the line PQ becomes the tangent at the point when x is 1 and its gradient is 2. So the notation that we would use for that would be lim, as h tends towards 0, of 2 plus h is actually, sorry, I don't need the equal sign, is actually 2. That's what we would say. So the limit of 2 plus h as h tends towards 0 is 2. And that's pretty much everything you need to know about limits.